Hello, my name is Tyler Rivera, and this is the pseudocode part for my project. Part B states the multiplication of two matrices. The user should be prompted to type in the dimensions of both matrices A and B. If the column number of A is not equal to the row number of B, the user should be prompted to check the dimensions and retype. If the dimensional condition is satisfied, perform A cross B and show the results. So, I would typically start this part of the project by creating a basic header file. So I can create a user-defined function just for the multiplication. So in that header file, I would start by creating three arrays, A, B, and C. I'd also add a couple of integers in there that would be used to count each of the for loops for every array. I would then create a prompt for the user asking what the size of the array will be and if the size of array A and B are not the same. If they are the same, I would make them retype the size of the variable until they both become the same size. This will all be done by using if-else statements. Once the sizes are formed, I will ask the user the value for matrix A, and I will record the values using for loops. As the loops grow, the value for each row and column will be set. I will repeat this for matrix B. Once the loop is over, I will continue with another loop that represents matrix B. Once the vertices are collected for both of the matrices, I will create another for loop for matrix C. And this matrix represents the total from the product of matrix A and B. Once this value is created, I will use a printf function to show the user the matrix C and state that this is the total. This is the header file, so I'll use this in conjunction with a main file that will house other codes for this project. And in that project, that's where a lot of other print functions will be stored. Going back to the multiplication part for step 4, I wanted to go over how I would kind of do it. I kind of give a little clip there, but it would be a segmented for loop with 3 for loops, and just like previous parts, like with addition and subtraction, I'd probably have 2 for loops, for I and J, kind of just fill it in. But this one would be IJX, so the third variable would be used for the rows and the column. The row for one of the matrices while you multiply with the column with the other matrices as stated by the rule for multiplying matrices. So that once you multiply the matrix you would add that to the third array segment that equals the product of the two. So it would more than likely be like the plus equals symbol, and then the matrix 1 times matrix 2, and in that those two matrices you would have like I times X times it by matrix 2 would be X times J. So it would keep moving with I and J, and then the two X's would kind of drive it. And I believe that should be enough for the product. So, part D asks the user to create a program that could take a system of equations with 3 unknown variables and 3 equations and use Cramer's rule to solve them for the determinants. So to start this, I will create a function used to determine the determinants. In this function, I will start by prompting the user to enter the value of 3 equations. The inputs will be recorded in 2 separate arrays, one for the x, y, and z variables. So that would be each variable will get a column and a row, and one array goes to the variables for at the end of the system equation, which you can actually see in this picture is D1, D2, and D3. So that would get its own array. The number will then be used. So that number will be used to replace the main variables as stated by Cramer's rule. So the D1 will replace the x's, the D1 through D3 will replace all the x's, and for each independent variable, it replaces it. So once the values are found, we need to find the determinants. So we create arrays for each of the new x, y, and z. So as you can see in the photo, we have a dx, dy, and a dz. So each of them get its own array. So now, for each of those determinants, we have to replace the x variables with the d1 values that we got before. And once we have those, we can find the determinants for each one. So now, once we have the determinants of all x, y, and z variables, we have to find the determinant of the whole system. So we create another array just for that one, and we calculate the determinants using the original variables. This is done by stated by the picture to the right. Dx, determinant of x over the determinant of the whole system, would be equal to x. So we do that for all three variables. After that, we would use the printf function to tell the user the answers. So, yeah. And once we do that, we're good. And this one, I might use another header file to actually calculate everything and bring it all back to the end. But this is what I have so far. So let's see how do I move. Oh. Thank you for watching.